a former president of this association. He has been very consistent and he keeps coming to activities. Thank you very much, sir, for coming. Also, our fellows online already, we have Mr. Alex Taka, FNAPE and past president of this association. You're welcome, sir. He's online. We have Dr. Jide Olufuyi, also a fellow of this association. And we have Mr. Folorunsho Karim, a fellow of this association. Without wasting our time, I'll call on the president. Madam President, please, your remarks. Thank you.
Good morning, everyone. Those of us in this room and our members and friends who are online. I welcome you all, our fellows, our past presidents, our active members, members of this association, students, and all guests that are with us here in this room and online. Thank you for honoring our invitation today. And thank you for making our monthly technical meetings success, because without your presence, we can't have a successful technical meeting. And I also want to say thank you to our sponsors, Seis-space, for sponsoring the August technical meeting. And I can see some of those who sponsored the March technical meeting. That's Boca in the room. Thank you very much, because I know that in one way or the other, you have a relationship with Seis-space. Thank you very much. Today's theme is Beyond Site Survey Design, Optimizing Infield Activities, Intelligent Data Processing Workflows, and Enhanced Presentation of Results. You agree with me that it is particularly relevant at this time as our industry continues to embrace new technologies and more efficient way of working. And as explorationists, our work is beyond seismic acquisition or data design. You know, we know that success of a design is beyond the design, is just beyond the parameters. We must consider how effectively we use that information to carry out activities on the field, and how intelligently we process and integrate the data to acquire and process the data to have a good survey that we can work with for business decisions and exploration activities. So I believe that our sponsors today and speakers, panelists, are subject matter experts. You know, from their profiles, it shows that they are subject matter experts. And as an association, every month, every topic, you know, we'll talk about, we bring the subject matter experts to speak on them, because our platform is for learning, for sharing experiences, and also learning from others and exposing our members to ideas that will help them function well as explorationists. So I want to encourage us all to sit back, listen, take advantage of what we are getting today at no cost, ask questions, concentrate, if possible, put your phones aside, so that at the end of the session, we'll have ask meaningful questions, listen to comments, and go back to our workplaces and put into practice what we'll learn here today. So once again, I want to say thank you to our sponsors, to our chairman today, who has taken time to come here to share this occasion, and also to our speakers for taking time to come to share the knowledge they have. Thank you very much, and I hope we all have a pleasant time today. Thank you.
Thank you very much, Madam President, for that remarks. We'll now go to the next item on this agenda, which is introduction of the chairman, and then in turn the chairman will introduce the speaker and all that. But before then, I would want to invite the speaker, the panelists to come on stage. It's only when the presentation starts that they might go back. So I will call on Mr. Osim Ogboke, who is the chairman of this session, to please come up. I also want to call the speaker, Mr. Christopher John Alger, to please come up. Mr. James Ukachukwu was supposed to be with us, but unfortunately he couldn't make it, so he has designated Mr. Reginald Ofebu to represent him. Mr. Ofebu, please come. And then we have Engineer Dozie Irrechukwu, please, on the stage. So, yeah. So about the chairman of this occasion, Dr. Osim Ogboke. Dr. Osim Ogboke is a chartered professional geoscientist and a process certified change management practitioner with 19 years of oil and gas industry experience. Combining technical expertise, commercial insights, sound judgment, and proven leadership in asset management. He holds a PhD in sedimentology and stratigraphy, an MSc in applied geophysics, and a BSc in geology. By the way, the chairman, schooled in my alma mater, UNN, so we pretty know very well. He's a lion. He currently serves as Deputy Manager, Funding Administration at NNPC Limited, where he supports end-to-end asset group management, budget planning, and performance governance. He is well positioned to drive disciplined asset governance, effective stakeholder alignment, and value-focused delivery across complex JV operations. Ladies and gentlemen, permit me to welcome our chairman for this session, Dr. Osim Ogboke. Thank you very much, sir. So I will. Is it? So without wasting our time, I will hand over the mic to Dr. Osim to introduce the speaker, and then they will all move down and then listen to the presentation and then come back again for panel discussion and then questions and answer. So, Chairman, sir.
Thank you very much, colleagues and fellow NAPE members. Mr. Christopher here, I just had a chat with him just before all of us came in here. So Mr. Christopher John Alger, that's his name. He has over 25 years experience in offshore side investigation projects. And he covers oil and gas, wind farms, cable route sectors. He has worked for peak processing as principal interpretation geophysicist for over 10 years and has exposures in acquiring, interpreting, reporting of the data sets worldwide, having previously worked for companies in the Eastern Asia, Australia, and in the Middle East. He also he has worked with Mr. James, who is our co-sponsor here, on numerous rig site projects, pipeline route surveys over the past 10 years in relatively shallow water. That's waters between 30 and about 50 meters. In Nigeria, and I also have provided site-specific regional geohazards for deep water wells in Nigeria, alongside in West Africa. So, ladies and gentlemen, my colleagues here, please join me to welcome Mr. Christopher. Yes, that's right. Thank you very much.
Thank you very much for that kind introduction, and good morning, everyone, and thank you for having me. I'm going to sort of follow on from what I talked about last time. So previously we talked about the concepts that drive the design of a site survey and taking it from the first starting point and what we need to look at. This time, that's all been done. We've reviewed the material we have on the area. We've adopted a survey strategy. We've considered what we might encounter, and we've applied for permits, and we're ready to acquire a site survey or a site investigation. And so we are going to sort of talk through the steps that we would go through from being awarded the work. So we've won the work, we've tendered, we've come out on top. We're then going to look at selecting our vessel, selecting our equipment, suitable equipment for whatever the environment may entail. So as we mentioned last time, we might be working from 2-3 meters of water, possibly less, all the way up to 2,000-3,000 meters of water. So there's a wide range of environments we might be working in. We'll have a little look at offshore personnel versus remote QC. This is sort of an emerging technology. Companies are now putting unmanned craft into the field with remote sensors on board, and then remote workstations in a office, can be anywhere in the world, can be on the beach in a hotel, but they'll be putting these together. So no one's offshore taking any risk anymore, and that data is still being processed in real time. We'll look at the software we process that in, what we do to the data, and how we meet the scope of work, because ultimately, once we've won the work, we have to meet the scope of work with what we present to the end client. And we'll have a look at the way that's presented, because these surveys can cost tens of thousands of pounds up to millions of pounds. And all that you're left with, first of all, hopefully, is a safe project where there have been no incidents, because that's the first thing that a client remembers. And then a report that used to be printed and put in a nice binder and kept on a shelf somewhere, now is a PDF that just gets viewed on a laptop. But that's the final stage, along with a series of deliverables and possibly a GIS. So we'll work through all of that. Firstly, we need to design our survey area, and there'll be several components that start that. There will be a location that someone wants to drill. That will be their preferred drilling location, and therefore the survey should be based around that. The spread of the survey and the size of the survey depend on the context survey. If you're installing a jackup rig, you don't need quite such a big footprint on the seabed. You need to know what's going on within probably a kilometre or so, but no more. If you're going to be using a semi-sub in 2,000 meters of water, the semi-sub will have quite a large anchor radius. So the survey obviously has to be larger and scaled to fit that anchor radius. If it's a pipeline route, there'll be a preferred route between 2 points. So that will be the route, but then the corridor needs to be selected to allow for potential development should any hazards be presented along that route. So if you know it's a relatively benign area of limited hazards, flat seabed, no expected problems on the seafloor, the corridor could be narrower. If you're uncertain of these things, or you've got lots of slopes, potential UXOs, potential shipwrecks and things, the corridor may need to be wider to allow development work to take place. But all of this starts from a starting point, and then the survey plan is designed outside of that. the survey platform. So again, very shallow water, you're not going to want to use a really, really big boat. That's going to create a lot of noise. The survey sensors themselves create noise that interfere with each other, but if you've got a big boat that's also interfering with those sensors, acquisition becomes very, very difficult. So in shallow water, the smaller, quieter boat, what we're looking at. So I've sort of split this into 5 categories. So we've got a nearshore survey vessel there, very small, only able to work during daylight hours generally. Limited space for crew, so you might have a couple of people on board and a captain. So in that sense, the crew need to have a wider range of skills to be able to cover the tasks they might need to do, whereas as you move up through the bigger boats, the staff on board become more specialists in their area. But if you've only got a couple of people, you need to know your stuff. They obviously have a very low weather tolerance, so they can be tricky and you can end up with a struggle to survey. I worked on a project probably 2 years ago where someone in the North Sea had decided to do a survey in January and February on a boat very similar to that, and they spent 50 days acquiring nothing. So complete waste of time. We then move up to something sort of a little bit more stable, probably not so useful for working in shallow water, but for water depths of 10 to sort of 50 meters, very suitable. And this kind of craft, a 30-meter survey vessel, has become very popular in Europe for wind farms because they're all in about 30 meters of water. Again, you can fit a few more people on board, you can fit more kit on board, so you can acquire a few more types of data. You probably couldn't conduct a geophysical and geotechnical campaign in one cruise from that vessel. There would need to be some changeover and a bit of a split. So it has its drawbacks there, that it's not a sort of complete solution in one go. We then move up to the sort of very typical survey craft. So 60, 70, 80 meters, capable of housing geophysical and geotechnical equipment at the same time. A lot more people on board, a lot more weather tolerant. And this is the kind of craft that generally site survey investigation work in 100 meters of water is carried out with. Just for a little bit of scale, we then move to a 3D ramform, massive vessel collecting 3D surveys. Wouldn't have the flexibility of a lot of the other craft, but for what it's doing, it's the right tool. And then the last, and this has become very popular in the last few years, unmanned survey craft. The big plus of these is there's no risk to personnel. So the craft with the sensors are sent out into the field. They have a survey line plan sent to them that they then just follow, they tick on through. And the data can be sent straight back to shore for processing, QC, and interpretation in real time. They're very popular for just sort of seabed survey work and pipeline, cable investigation, because at the moment, no one has successfully managed to acquire seismic data off one of these vessels, so they are sort of limited to multi-beam, sonar, and sub-bottom, but people are working on that at the moment, so that probably is coming. Once you've selected a survey craft, it needs enough space to be able to do whatever you need to do. So if you're acquiring seismic, you need space for a streamer and some guns and compressors on the back deck. So you wouldn't be able to do that off the small craft, nearshore craft we looked at. And even with the sort of 20, 30 meter vessel, there needs to be some thought into how that kit is laid out, because you need a little bit of space. We also need enough space if we're doing survey work to have a crew on board. We need bunk space, We need to be able to house everyone that is required for that job. So a little bit of thought and optimization of the layout is crucial. I've worked on boats over the years where you've had to contort your body around cables, spools, all sorts, to just get to kit on the back deck. And that's where people haven't given that enough thought. And you've ended up placing bits of equipment in the wrong place, or you've forgotten about a piece of equipment, and then suddenly it's become a panic. And a very crucial step there, once we have placed the equipment on board the vessel, is actually measuring where that kit is relative to our survey antenna. So we'll be getting positioning fed to the vessel, to one position on the vessel, and then every other sensor is offset from that position. So accurately measuring those offsets is crucial. If those offsets aren't measured accurately to start with, we end up with an error. And with all of what we do, it's not absolutely exact as a science. There is a little error budget, but you're always trying to minimize that error budget as much as you possibly can. So the more accurate your measurements of the sensors and their tow points and their various locations are, the more accurate your survey will be. So there can be a DIMCOM survey whereby we've got someone with a station actually very accurately to like centimeters measuring every single offset, or traditionally a tape measure has been used. And again, as long as it's done accurately and checked, it works perfectly well. But we need to know where everything is to try and minimize our errors. Our sensors. So typically in site investigation work, we want to know the water depths, what potential hazards there are on the seafloor, what the soils are like for situating anything, so putting down a jack up, maybe piling, etc. Whether there are any hazards subseabed. And then as we get deeper and deeper, we think about gas and faulting and so forth, things that could cause a problem when we're drilling. So we're looking at multi-beam and single-beam echo sounders first. Now these will give us an idea of the water depth, a very accurate idea of the water depth in the case of a multi-beam, a slightly less accurate depth with a single beam. They will also show us potential hazards on the seafloor. So if there's a shipwreck, we'll be able to see that with a multi-beam. We wouldn't be able to see that with a single beam. The concept of both, and if you see in this drawing here, multi-beam will acquire a swath of data, generally about 3 times the water depth. So if you're operating in 30 meters of water, you can acquire a swath of 90 to 100 meters. A single beam will just acquire 1 point down the middle of that swath there. So you get 1 water depth. Where single beams have an advantage is in very shallow water, because obviously if you've got very shallow water, to acquire multi-beam data, you need to run a lot of lines and it becomes very expensive. So if cost is a consideration, a single beam in shallow water might well be used. These also work from a few meters to thousands of meters. And depending on the water depth, that tailors which type of multi-beam you choose and what you use. It's worth considering with a deep water multi-beam setup though. You might well go and acquire that system, but what you'll come back with will be no more accurate if the water depth is great enough than the seabed pick from your 3D exploration cube. If you've got a good 3D exploration cube in 2,000 meters of water, that will be far more accurate than a multi-beam that has quite a large footprint on the seafloor. So there's some times where actually you don't want this equipment on board. You won't be gaining anything from it, and you'll have wasted quite a bit of money. We got, does that point? Is that one? Ah, right. So when acquiring a swath of multi-beam data, This is a typical swath of multi-beam data. You'll need to accurately apply sound velocity, because obviously if our sensor is up here, this point has traveled a lot less far than this point and this point. So we need to know the velocity in the water column to accurately correct that depth sounding. So you'll see a lot of sort of frowns and occasional smiles in data that need a little bit of velocity correction. You'll also note that these three lines were probably acquired at around about the same time, and there's a tidal error here. So we need to apply tides, be that observed tides, predicted tides. We need a tidal correction to balance out our data, so we know exactly where that seafloor is. And again, the amount of sampling we would need with the SVs depends on where we are in the world. If we're near a river, we will need a lot more samples than if we're out in the middle of the ocean. So the multi-beam will give us water depth and some of our hazards on the seafloor. The sonar and backscatter will give us a lot better idea on the hazards we see. So point targets and anything sitting proud of the seabed, pipelines, boulders, bits of kit dropped off vessels or rigs, the sonar will see those. And yeah, its primary task is to spot contacts on the seafloor. It will also, if you've got a low enough frequency sonar, show you sediment contrast on the seabed, so you'll be able to pick out different types of soils. So from that you can potentially map possible soil boundaries, which will then need some correlation with some ground truthing to sort of to confirm the soils, but it's a starting point. Sonar basically images the seafloor. You get a swath, again, depending on the range you select, and the range is dependent on the frequency of the sonar. So with everything we do, higher frequencies lead to less range, lower frequencies more range. Higher frequencies obviously have a lot more detail. You can see a lot more. Lower frequencies, less detail. So there's always a payoff there, and these things have to have been considered before the survey starts and the line plan designed. But what comes back from that sonar is an intensity value, which can then be plotted as a swathe and joined together. And I think if we go on to the next slide, we will see some examples. Have I jumped to there? No. Examples of intensity changes within sonar data. So on this example here, we have this very, very light grey area, and then we move into a slightly darker grey, and here we can see a linear, sort of quite high reflectivity area. So I think this was interpreted as a very soft clay, and this was a more sandy clay, and this is a backfilled trench from a pipeline, so coarser material has obviously gathered in there. And there's an example of the ranges that a frequency will travel. So you can see with a very low frequency, 100 kilohertz, you can acquire data over a large range. There will be less resolution in that data, but that might be very useful. Whereas if you move up to very high frequency sonar, we don't acquire very much range. And here we have very high frequency sonar. This is an example of bad data acquisition. Because we've acquired data, there is no data here. This is mostly just noise, and exactly the same here, mostly just noise. And because it's very high frequency, it's more susceptible to the weather. So we've got some banding within the data, and we haven't acquired any data where we think we have. So that's always to be considered. We also have backscatter data here, same area, shows the same kind of things. You'd probably argue that the backfill trench was clearer. This has advantages over conventional sonar in that its positioning is spot on because it's not towed. So the sonar is towed behind the vessel and relies on positioning from an ultra-short baseline, which, depending on the distance from the vessel, the accuracy diminishes the further you go. So there is going to be a few meters of error in the positioning here, which you try and correct for, but because the fish doesn't have a gyro or anything on board, it's very difficult to get it perfect. This has perfect positioning. But the sediment contrast isn't as good, but certain features can be picked out very nicely. So useful to use in conjunction with sonar, but can't really replace it. As this is mounted on the vessel, unlike the sonar, it also doesn't show heights of objects and how proud they are of the seabed. So it's useful, but not going to take the place of sonar. Magnetometer and UXO work. So UXO work is something that is done a lot in Europe because of munition dumps from World War I and World War II. The classical magnetometer is just a single mag, towed behind the sonar at the line spacing, looking for pipelines, wellheads, and any other ferrous objects on the seafloor that might be a problem. It's great for confirming positions of wellheads and pipelines, but it doesn't really tell you too much more. Whereas a UXO, we tow an array of mags. You can tow any number of these basically, and it sort of became competitive in Europe to see how many of them you could tow behind a vessel to actually completely gain a swath of mag data to then be able to pinpoint the exact positions of magnetic anomalies. And I'll show some examples of that in a while. It's very costly. Takes a lot more time because you actually have to fill the whole of a grid in rather than just a single line every 50 meters. Sub-bottom profilers. So we're now looking at the sub-seabed, and we are looking to try and map the soils that could provide a constraint to installing a jack-up. We're looking for things that could potentially offer punch-through. Shallow hazards, so there may be a buried object just below the seafloor at a point where a jack-up leg is going to be placed, so we'd want to know about that. Again, the same that we've talked about, frequency and resolution and penetration. So with a sub-bottom profiler, and you see it a lot where people show you an example of data and it's beautiful and it penetrates to 50, 60 meters, and they'll ask, why can't you get that? Well, they are defined by the soils. So certain soils, you get lovely penetration from a sub-bottom profiler. Very soft clays, as we'll show in a while, brilliant penetration. A coarse sand, they really struggle because they don't have enough punch. So if you're in a coarse sand, you'd want the lower end systems there, boomer or sparker, whereas if you're in a soft clay, the Innomar or the chirp would work well. And this is where knowing what the soils are going to be like that you're going to encounter is crucial. And if you haven't got an idea of that, then you often end up taking 2 or 3 sub-bottom profiling options rather than just one, because you don't know exactly what you're going to be using. I should also mention that the first few options tend to be mounted to the vessel, so they have more accurate positions, whereas a boomer and a sparker will be towed behind a vessel, so they're a little bit less accurate in terms of positioning because there are more uncertainties, but then they have a bigger footprint on the seabed, so it's not such a problem. And then into the 2D HR, 2D UHR seismic. So again, we're looking now at the deeper geology. but in more detail than you get from the 3D cube. So generally acquired to about 2 seconds below the seafloor, 2-second record length, which, depending on the geology, can be anywhere from 1,500 meters to 4,000 meters if you've got competent enough rock there close to seabed. Very classically for oil and gas work, you would use a 96 channel streamer with a sort of 12.5 meter group interval, anywhere between 80 and 180 cubic inch guns, and a shot point interval of about 6.25. So that's fairly standard. As we go into the ultra high resolution, shorter streamers, shorter group intervals, shorter shot point interval, which again leads to more resolution but less punch. And that's kind of the key element of all this, is getting the right kit for what you want to achieve. Oh. And this is basically what we do with the HR, UHR. This example is trying to show you how we build fold of cover along our survey line. In this example, we have a 24 channel streamer. And as you can see from this, it takes us 24 channels. So we've got to survey the length of 24 channels before we get to having 24 channels worth of data to stack together. So we have very little data where we start out, and then we get to the point where we start to get the 24 channels. And what we are basically doing is sampling that point on the seabed, or as close to that point on the seabed, 24 times. We then stack that data together, which is basically an averaging process, that then allows you to more accurately define the reflectors and so forth at that level. I'll show some more examples in a little bit on this. But yeah, is basically what we're doing with 2D data. We also have geotechnical and environmental data that gets fed into the survey, usually conducted by experts within those areas. I'm not an expert on either. I know how to integrate the data, but the acquisition of such, I wouldn't get involved in generally. But we need to ground truth both the seabed and the subseabed to make the result of our sub-bottom profile or our side scan sonar much more accurate. Without that information, it's a guess. Now, you can make very good guesses if you're experienced and have worked in that area before, but if it's a frontier site that you know nothing about, it's very difficult to say what the soils on the seabed are and subseabed with any certainty. You can make assumptions based on what you see, certainly subseabed in terms of the way that the geology and the reflectors look, but without that actual extra data, you're uncertain. And the same with the seabed. You can assume that higher reflectivity is more coarse material and lower reflectivity is softer, less coarse material, but you don't know exactly what the range you're seeing within your site is without some form of ground truthing at the top end of the reflectivity and the lower end of the reflectivity. And then you can make a much better interpretation. This is probably the area where site survey has moved on most in recent years, in that we used to go out, work for 4 weeks, 6 weeks, however long. You'd have occasional email communications with the office, and everyone on board would work on the data. It'd come back, and then it'd get passed to the office, and we'd look to report it. These days, everything is getting beamed back to the office pretty much in real time. There are obviously some very good points about that, and there are some very bad points about that. I would argue the bad point about that, it has lessened skills offshore, because if people run into a problem, they generally just send it to someone on shore rather than trying to sort it themselves. And if you don't spend some time looking at that and trying to figure it out yourself, you're never going to upskill yourself. How you learn is by making mistakes, unfortunately. But it does mean that you can give results to clients very quickly. If there is a rig on standby, you can get something to a client to mean that rig can move in very quickly. So it's got a lot of advantages as well. It also means you need less people offshore these days. So it has some good points. And what is also popping up a lot now is remote data centers, where you'll have 2 crews working 12-hour shifts, but in an office, so they get to go home to their bed if they live nearby, or a hotel if not, which is a little bit more comfortable than a survey vessel. And they just work on the data as if they were offshore there. That's their job for 4 weeks, 5 weeks, 6 weeks, whatever. They sit and do what they would have done offshore previously, just in an office. So there are some definite perks for people's lifestyle and health with that. They like running or whatever, they can go out and run before they go on shift and so forth. So yeah, they're becoming very popular. And the other thing with increased frequency of all sensors, so the desire to constantly be able to see smaller and smaller targets subseabed and on the seafloor pushes up file sizes. And where you used to be able to store stuff on a single tape, we're now getting to the point where we've got massive data centers storing a whole heap of historical data. And that archiving becomes more and more complex. And I think I might have told this story last time, that we were doing a desk study for a North Sea decommissioning project. It was a rig that has been in since the 70s. At the time, they did some geotechnical data. The rig has spawned quite a lot of other rigs and infrastructure over its lifespan of 50 odd years. And it was going to be very costly to go in and acquire a new borehole right next to it to allow decommissioning with a jack-up next to it to take place. But actually, a contractor was able to locate that 1970 geotechnical borehole in their archive, which saved quite a lot of money. I would think that runs to hundreds of thousands of pounds, because that was going to be very complex. So these things are crucial. Being able to lay your hands on historical data can save you a lot of money. Right. So now we're going to look at how this data looks once we have processed it, presented it, tidied it all up. So this is multi-beam that we see down here, where we've got some mismatches, misaligned swaths. We've got some frowns. We've got a bit of roll possibly here that it's not aligned properly. And so the job of a multi-beam processor is to correctly apply sound velocity to all of that data, to then apply a tidal correction and apply any mismatches that you need after the tidal correction, because there are other factors at play. You'll start a job with a vessel that's weighed down by a load of fuel. You know what the draft measurement is at that point, but by the end of the survey, the draft measurement probably won't be the same because the fuel has burnt off. And that will lead to small misalignments within here. So that all needs to be considered. You'll often find as well, obviously, data at the central point right under the sensor is much more accurate than when we get out to the extremities because of the travel time and so forth. So it may well be that some of that data gets trimmed. But what we end up with is a very nicely presented map of the seafloor topography, where we can see the slopes and we can see features. And that is the aim. some raw side scan sonar data here. So this is as acquired. So this is the two channels, the port channel and starboard channel of the fish. You can see straight away a difference in the intensity either side. You see signal decay. So again, strongest at the nadir, under the fish, weakest out at the very outer ranges. We've got some constant noise in this data. So that's a bit of a problem. Can't do anything about that in processing. Once that's there, that's there. But what we do is take all of the data and basically through a variety of different averaging and normalization filters, we blend that data. So what we have is an accurate representation of the various intensities across the sea floor. We'll also track the seabed, so we know accurately where that is. And by tracking the seabed, we can then do what we call slant range correction to remove the water column and produce our sonar record. And again, this gets put into a map, and we see the various intensities. So I think this is a shale and sand, and you see the way the map has been built up through each of the single lines there, and how you can see features across the lines. So the positioning is pretty good, but you do still see minor contrast even when it's been fully processed between lines of data. And here we have an example of some of the processing that is carried out to correct that signal decay, to slant range correct and reposition everything. I think this one has a nice example here. This isn't real, this feature. This is where the seabed pick is poor. And so that would be something you'd need to go back in and have a look at. But the rest of it, seabed has been well tracked, and then we see a poor seabed pick. There we go. And some examples of contact seen on a seafloor. So this was from one wind farm site in the North Sea that had the busiest seabed I think I've ever seen. It had everything going on. There was an awful lot of fishing pots and strings of fishing pots across the site. And a lot of stuff that I couldn't really explain. Here we have some very linear features with bits of pieces going across it. Is it some form of fishing debris? Possibly. Wasn't really sure. It covered about 60-meter area, so it was quite large. These were potential for containers that have fallen off ships laying on the seabed. And you can see the shadowing, the height above seabed of those, and the really nicely angular shape. And we have those features on the multi-beam as well, just to correlate. This is what was interpreted as a wooden fishing craft. No magnetic anomaly off it, so we guessed it wasn't ferrous, but it has kind of the perfect shape for a small pleasure craft. This, I have absolutely no idea what would have been 12 meters long nearly and sitting 50 centimeters per out of the seabed, but only 40 centimeters wide. So it's quite an odd kind of target. It could well be something that's fallen off a ship, but yeah, it was very difficult to gauge. Some fishing debris. Again, we've got the wire off it, and some pots that you can see. You can see the fishing pots and the anchor there. A tire, obviously fallen off a vessel that's been using that as a buffer, and some more fishing gear. So this site had absolutely everything, but it's in a busy area in the North Sea. Generally, sites aren't that busy. magnetometer now, and this would be very typical for an oil and gas site where we just have a single line of data and we have an anomaly, and we know that that anomaly is where it is. It's seen on a line. If your line spacing, for instance, is 50 meters either side of that line, and you only see it on one line, well, that anomaly could be anywhere within 25 meters of that line. And so you're not very certain of its position. This is the UXO processing where we actually, again, acquire a swath of data, and you can start to pinpoint exact positions of anomalies. So it's very useful for accurately pinpointing discrete targets. This is brilliant for finding pipelines because you're going to see them on more than one line, and there should be a linear trend. So it still has its uses. Sub-bottom profile of processing, we have the absolute raw data. We see all the motion of the vessel in the sea floor, and that will correspond with the subseabed data. We also again see that signal decay as we drop further below the seafloor. So once we've processed that, we would pick the seabed. We would heave compensate or swell filter to level out the seabed to provide a best representation. We can match that to the multi-beam if we wish. And then we apply some processing to revive the gain down the record, be that a time varying gain to boost the signal down here, or various other things. We've also applied a water column mute to hide some of the striping. Can't really see it on the screen, but there's sort of constant striping noise in the data, and that can be removed as well. But just the picking of that seabed, flattening it, that makes everything look clearer because you take the motion out of the underlying reflectors and everything sits a little bit better. And this is a section taken into our interpretation software. We would do all of our interpretation in Kingdom software, where we can map our horizons, map our seabed, and you get to look at how the data looks across the area. So you can tie it into adjacent lines, cross lines. This isn't a great example because it's along a pipeline corridor, so there are no cross lines. But if you've got a site with cross lines, you can see where your intersections occur to try and make sure everything is matching up. But it allows you to visualize the data in plan view and in cross section at the same time to keep an eye on what you're doing. The software, and again, not the data to explain it on, but this would also allow you to do amplitude extractions, time slices, and so forth if you've got 3D and 2D data. And then just the presentation of this, we will then take these map surfaces and create isopack maps to show where things are below seafloor. So obviously very important if you're situating a jackup rig. Great location over here because the geology is pretty uniform thickness wise. Not such a good location over here because we've got some slopes. Geology not quite so uniform. We'd have to consider things here a little bit more. So that is kind of things that we're trying to produce to aid the safe installation of whatever the job might be for. With the multi-channel, we would seismic process. So the seismic processors, and we have a team of seismic processors who work on just processing 2D data, very similar to the stuff you would do with 3D data. Obviously, a lot of this is just single line. But taking a data set from start to finish, we'll try and remove the noise, remove the multiple. That is where multi-channel has a significant advantage over the single channel stuff that we've just looked at, and that you can remove multiple. There are ways now of removing multiple within single channel data that has kind of emerged in the last couple of years, but you'll often hit primary data as well, so you end up with a bit of a payoff. Do you want to remove that multiple and remove real features? Probably not. The data will be enhanced. Velocities will be picked. 2D velocities, not as accurate as 3D velocities, but accurate enough for what we're trying to do with the data. And then we will migrate that data and put it into a stack. And here is an example, 48 channel streamer. These are the raw shots. We can see the move out, the natural move out as we go along the streamer. So that's the nearest channel, that's the far channel. Got a move out there, and this is what happens when we stacked it all together. Applied those processing steps, removed the multiple, enhanced the data, tried to remove all of the noise as well, because you can see lots of noise through this record. That's all gone now. And so that is the final product. And that leads us to various geohazards. So we've got some examples of shallow gas, very striking examples of shallow gas that are quite obvious and couldn't really be missed. We've got some mud diapers, some sand injectites, and some pockmarks. Obviously, all of these features are gas is playing a part in them. These are historic sand injectites, so the gas has dissipated when the seafloor was lower, so there was no gas in any of these days, but there obviously is still a pocket of gas under this pockmark, and you wouldn't want to situate anything there because you can't really tell what's going on. There we go. Other geohazards, deep channels. So again, obviously we wouldn't want to be situating a rig on the flank of a channel because we've got very variable soils over potentially the rig footprint. So key to know where channels are. Contourites. We've got an example of a debris flow that's moving towards it, and we can see the head wall of where that debris flow actually kicked off from, and faulting. So all kind of things that we would be looking for to map. These are the kind of things that oil and gas companies will want to know in that top section before they drill that well. And they have to mitigate for several of these potentially. Just how we display it. So here's an example of the difference between 2D data and the resolution of 2D data and the resolution of 3D data. So it's exactly the same area. You can see the gas hazards. They match up, but you've just got a little bit more detail in here and a bit more accuracy with what you're picking, which might not be a problem, but if it's close to your location, it would allow you to more accurately map as long as you have the data density from the 2D. And the integration of data. So we talked about acquiring the geotechnical data. Well, the geotechnical data then gets overlaid with the sub-bottom profiler, UHR, to accurately map those sediment boundaries. And very often, you'll have mapped very obvious sediment boundaries, but once you get the geotechnical data, you might have to go back to your interpretation and map some more subtle ones, because if you've ground truthed it and it shows more variability than you first thought, you'll be going back in there. How UXO correlates with sonar and multi-beam, although that's not very clear to see, but we've got a contact on the seafloor that has a big magnetic response. So we can assume that that's a ferrous item, and if we're doing a UXO survey, will warrant further investigation, potentially with a camera. So here we've run a camera over what was assumed fishing debris, and we can see a wire or a cable that's got quite a lot of marine growth on it that match that position. A few case studies here. So this is offshore Angola, deep water. This is with an AUV. So we're talking remote operations here. The AUV's been sent down on its flight path, it's run its survey, acquired its data. Once we get to these kind of water depths, traditional towed methods do not work. We have to use something else. So it could be ROV, AUV, but we can't be using sensors fixed to the vessel because we lose all positioning, all resolution. Without getting that sensor really close to the sea floor, so running along here, we don't get the resolution in this multi-beam. So this is what you'll need in deep water environments to gain really good resolute data. And this was some really nice data. You see penetration on the sub-bottom profiler because we've got very soft soils. It's tens of meters. We can see nice ties between what we're seeing on the seafloor in terms of pock marks and faults. So we've got that fault there over here. We've got a little pock mark in there. We're just catching the edge of. Again, we've got a carbonate reefy kind of structure here and mounds sitting proud of the seabed, and we're able to map those and cross-correlate the sub-bottom, the multi-beam and the sonar. So really nice data, really clean, not too much noise at all, and presented really, really nicely. A quick one, just because it was something very different we did. This was in a river, so the river bank was basically along there and along there. We obviously had to acquire with that, but we wanted to try and get some intersections, because without knowing what's going on in this orientation, you can't always be certain of what you're seeing the other way. So in this example, because it was all we could do, we ran a couple of crisscross lines and this zigzag line. Not something you'd usually recommend with seismic data, but in this case, it was the only option. So it's the best option for the environment we're working in. It's not perfect. I think everyone knew that, but it was an option to get a little bit more data that helped with the interpretation. Some pipeline and cable inspection work. Again, this has been quite popular in the UK this year. Traditional methods, sonar, flying along, just offset from the actual pipeline. Here's our pipeline. There's the shadow off the pipeline. Here's where the pipeline is sitting proud of the seafloor. So we're seeing shadow underneath. So that pipeline's in free span and potentially a problem. We can see a historic rock dump, I would say, that they've tried to sort that out with, but hasn't worked. Exactly the same on multi-beam data, and this has become quite popular on certain assets in the North Sea in the UK, because the seabed moves so much that they have to do a certain pipeline inspection survey several times a year. And so obviously a multi-beam is a much cheaper solution, and because the free spans are so large, they're able to accurately map them. But that again shows where pipelines in free span. We can see where they've done some remedial work here and here, but obviously this still sits proud of the seafloor. There are other ways of doing this, and obviously on buried assets, the traditional method would be an ROV and a pipe tracker and some camera work, very costly, but has better tracking and accuracy. And if the pipeline is buried, you can at least confirm it, because we're working with a buried pipeline on sonar and multi-beam data. We're not really ever sure we're in the right place. So it has advantages, and I'm going to come with something that might be even better. Ooh. 3D UHR has become also quite popular, initially to try and pick buried point contacts of 50 centimeters up to 100 meters below the seafloor, which isn't really possible with the way geophysics works, to be honest with you. I think it's, yeah, you will see things that are the size of a car, but probably not 50-centimeter boulders. I think it's a bit of a pipe dream, but very, very good for mapping channels and so forth. If you've got problems with channeling on a site, a great solution. Quite expensive to acquire, just like conventional 3D, but quite useful. And this little picture down here kind of is a way of showing you what you get. This is a 2D survey. You can't tell it's two parrots because you only have 10% of the data, maybe. This is conventional 3D, where we can see there are two parrots, but they're a little bit hazy. And then that's a 3D UHR, where you can see absolutely what you're looking at and in good resolution, but probably not 50-centimeter resolution if you're looking for boulders. And this is an EBOS system. So this is very new. So people have been trialing them last year, late last year and early this year. It's a buried object sonar system. So it's basically a sonar / sub-bottom profiling system. The technology came about for potential UXOs. So they were looking to try and find UXOs on cable routes and things in Europe, where a lot of munitions have just been dumped in the sea. But where it's actually been used mostly is for finding buried pipelines and cables. And where it has a massive advantage, we can acquire a swath of data, just like the sonar, just like the multi-beam, of 20 to 60 meters, depending on tow depth and so forth, that can penetrate 3 to 10 meters subseabed, depending on the soils. But that is allowing people to find buried pipelines that they've not been sure about the accuracy of the database very nicely now. It's a lot cheaper solution because it's a towed system. It can also go on an ROV if needs be, but it's been being used towed a lot to find and accurately pinpoint pipelines and their burial depths. So it's something that's sort of coming online, and I think will become quite big in the next year or two. Ooh. And finally, just a quick talk on how we present these results once we've done it. So standard kind of reporting, you discuss the results, some tables of what we found, some data examples, and the text obviously talks around the data examples, some maps, just to show what the various thicknesses. This is talking about the sub-bottom, so talking about the various thicknesses of units within there, and so forth. And charting, so sort of north-up charts, fairly standard for site survey, locations. We'd have a series of charts showing the bathymetry, the water depth, the contacts, and so forth. Fairly standard stuff. Then into alignment charts, so we're talking about a pipeline route now. And with a pipeline route, we line up the various data sets. So we have exactly the same point on the multi-beam here as on the seabed features and the isopack and the soils, and then the shallow profile. And that's a fairly standard kind of approach that's been around for quite some time. And now something slightly more bespoke. So this was for a dredging project where they wanted to pinpoint the areas they needed to dredge. So we've got some slightly odd color bar here for the bathymetry, but the gray and the red are generally areas that they're not that worried about. And within these areas, that's their dredge zone where they want to try and remove a bit of soil. And we sort of did this in conjunction with some cross profiles to show what the potential was for the softer soils removal above the actual base bedrock. And my last slide, again, something that's become very popular, GIS databases. It's a great way of storing all your data and keeping it in one place. Generally, two options within the industry: ArcGIS, which has been around for a while, very expensive to run a license, but you can publish databases to non-paying users, so it has some good points. And then QGIS, which everyone is now using because it's free. Allows you to build a database. It's quite user-friendly. You import your layers and you can sort of see everything. And these are great ways of storing data sets to come back to, because it's much easier to look at something visually than a hard drive with a load of data on it. Anyway. Thank you very much for your time. And
Thank you very much, Chris. Please, a round of applause for him again, please. Thank you very much. You looking for something? No. Oh, okay. So Chris has done justice to the topic. Please, can I invite the chairman of the session as well as the panelists to come up so that we can go to the round of questions and answers and all that. Panelists, please. So while the presentation was on, some of our fellows came in and we have to recognize them. We want to recognize Mr. James Urife, F. Nape, welcome sir, and a former president of this association. We want to recognize Mr. Mascot Ogunjomiwo, a fellow of this association. And then Dr. Charles Otohile, a fellow of NAPE. Charles, welcome. So our executive committee members online, we have Mrs. Somime Oguntola, who is the PS, Public Secretary, and then we have Mr. Emeka Ezekwel, who is the treasurer. They are all online and with us. So I would quickly introduce our panelists so that they can give 2 to 3 minutes talk on what Chris has just presented, and then the chairman will continue with his summary, and then question and answer. So quickly, I will introduce Mr. Engineer Dozie Irrechukwu. James is represented by Mr. Ofuebu. So Engineer Dozie Irrechukwu is the Managing Director, Chief Executive Officer, Seis-space Geosciences Limited. We know that Seis-space Geosciences is the one sponsoring this today's technical session. So he's the Chief Executive Officer. He's a distinguished oil and gas professional with over 43 years of experience in Nigeria's petroleum industry. He spent 3 years with the Department of Petroleum Resources, which is now NUPRC, Nigerian Upstream Petroleum Regulatory Commission, and retired as Deputy Director, Technical Services. In his senior leadership role, he provided strategic direction and oversight in the following areas: health, safety, environment management, petroleum industry data management, information technology systems, royalty administration, and related regulatory matters, as well as technical and operational compliance. He led the efforts and set up the current OSP that is required for offshore activities in Nigeria. A highly experienced HSC management specialist, Engineer Irrechukwu, has contributed significantly to the strengthening of regulatory oversights, operational safety, and technical excellence within Nigeria's oil and gas industry. He holds a bachelor's and master's degree together with several professional diplomas and certificates obtained from respected institutions, including Texas A&M University, Corpus Christi, USA. He currently serves as the Managing Director and Chief Executive Officer of Seis-space Geosciences Limited, where he provides strategic leadership and promotes the delivery of innovative geoscience survey and technical solutions to the energy industry. Ladies and gentlemen, Please, may we put hands together for Engineer Dozie Irrechukwu. I want to quickly take that of Mr. Ofebu, who is representing Mr. James. James is unavoidably absent. He couldn't come in from the UK, so he asked that Mr. Reginald Onyorioha Ofebu to represent him. So Mr. Reginald is the Managing Director, Chief Executive Operations and Chief Technical Officer, an expert in oil and gas exploration, appraisal and development, with over 30 years of experience in subsurface interpretation, field development, and reservoir management. Specialized in planning and executing oil and gas field development plans, and he has retired from Chevron as an asset development manager. He retired in August 2021. Currently consulting for local and international oil companies to discover and develop reserves. Experiences include Managing Director, Energy and Natural Resources Consultancy Nigeria Limited, Chief Consultant, Seis-space Geosciences Limited, Chief Technical Officer, Dimitere Nigeria Limited, currently, then Consulting Associate, Breeze Energy Nigeria Limited. Presently, is the Executive Director Operations, Boca Energy Resources Limited. His education span MSc Geology, Colorado School of Mines, BTech Applied Geophysics, as well from the Federal University of Technology, Akure. He's a member of NAPE, NMGS, APG, SEG, and SPE. Additionally, I want to also introduce somebody who works with Seis-space Geosciences in the person of Mr. Sunday Alabi. Is he here, Mr. Sunday? Yeah, welcome, Mr. Sunday. He's also part of the Seis-space family. Mr. Sunday Alabi is an experienced geophysicist with over 18 years of industry experience in geohazard surveys, identification and analysis. He currently works with Seis-space Geosciences Limited as their party chief on all their 2D high and ultra high resolution surveys from near shore to shallow waters to really deep waters. Thank you very much, audience. I will now hand over to the chairman of the session to the panelists so that they can just give us 2 to 3 minutes talk before the chairman can take over. Please, Dozie, are you going to come in? Thank you, sir. Then after Dozie, if Ofebu wants to say something again, you can always. Thank you very much, sir.
Good afternoon, distinguished colleagues in the oil and gas industry. He has introduced me, Dozie Irrechukwu. Before I begin to claim to be a geophysicist, I have people here who trained me, the likes of my Oga, Chief Chambers Oruwari Oyugbo. So if I tell you younger ones that I'm a geophysicist, he would begin to wonder, but I know Dozie is not a geophysicist, so when did it turn to be? And Chief Jim Murife, who also knew me from my tender age in the oil and gas industry, both of them are seated here. So I will not claim what I'm not. Therefore, but however, given a brief analysis of what our good friend Chris Alger has stated, some basic things he has brought to the fore, very fundamental things. They may look very elementary, starting from elementary things to the very high basic things and so on. But they're very essential things that any explorationists would want to take note of. There are very basic things that if you don't go through these processes, you might just be getting yourself into very challenging times. I've had that experience since I've been running the Seis-space Geosciences Limited. So it's I invite you all as explorationists and professionals in the oil and gas industry to take note of what has been discussed, which is actually a higher level discussion of what happened the last time he also made a presentation. And I think it's very good advice and some basic tools, basic guidance notes that has been put down this morning, this afternoon, for any explorationist who is going to do any form of work in exploration in our region, or indeed any part of the world, to take note of. I'd like to stop at this point. Thank you, because I know that I'm going to come back to say something again.
Good afternoon. I'll be riding on existing protocol. Before I do so, however, I must also emulate my organ and recognize some of the very eminent people who picked me up from the cradle. And I cannot but recognize my father, Oga Jimorife, under whom I started as a trainee geophysicist several decades ago. Yeah, I haven't said that. I think I have all the time to spend with him when we're done here. I want us to take some nuggets off the brilliant talk that Chris, as usual, has given us here. And I'll try to wrap it up around the strategies that we must pay attention to in scoping for a campaign like this, right? We are in a place now where the entire industry fully understands that your site survey is not just that nice to have thing. We've luckily come to a place where we have, by experience, been beaten enough to know that stepping aside or putting aside the little money that I would spend to be sure that we're safe is actually being foolhardy, because we've had to go through so many accidents in the industry. So having set that aside, some key things we must pay attention to in designing an efficient survey. One, we must first start from the economic perspective, efficiency. What exactly is the object of the survey? What is the scope of that object? What environment are we looking at? We need to capture all those. And then when we do so, we now come down to understanding impacts such as the safety of the operation and how expensive that could be if we blindly go into a scope that exposes a crew unnecessarily. We have to start thinking again of environmental, stewardship in this day and time when you count, the carbons, let alone the traditional, footprint metrics that we capture, and the world is taking very, very seriously now. So we need to understand that all those have to be in an efficient scope that delivers the objective that we are setting up at. When we've done all that, the next thing will be to sit down with an expert, reconcile all that, and then select the right tools or the right suite of tools. That alone goes a long way to determine whether we have a successful campaign or we're just playing around a playbook that doesn't exist. Because when you talk about site survey and design, there's no such thing as all size fit. It has to be specific, to the problem, which has to be framed appropriately by the right experts, and which has to reconcile all the factors I've spoken about to design a strategy that gives an optimal, safe, and economic design. So that's just what I would like to leave us here with. I took a couple of notes on some of the technicalities, but I mean, Chris has done justice to most of them, even as I was putting the notes together. So I think there are opportunities here to engage with Chris once more, or to engage with any of the Seis-space crews. There's a lot we could talk about, but there's so much time to do that now. Let me just leave this with us that in determining the overall cost of a project, it's very important that at the beginning we identify the risk factors and the uncertainty factors, and we deal with them upfront. That way it saves so many of the bad outcomes that we typically find in the field. Thank you very much. I'll leave it here.
Thank you very much, Mr. Ofuebu. So,
Okay, thank you very much. I think you have done a lot of things already, which I was going to speak about. I think you really summarized the presentation. Thank you, Chris. Very enlightening. You taught us like we're kindergartens, and I like the way you have put it. Thank you. So just to put summary to what Chris has done to this presentation, which is basically looking beyond the survey design, because like he rightly said, yes, it's all about strategy, but what is key here is skill. You know, in geology, we talk about skill. It's not about how big it is, it's what specifics are our interest. So basically, it's in a nutshell, is to build a simple fit-for-purpose design that you need to carry out your strategy so that you can avoid misharms. Some of us already know about the kind of issues that we have in the deep offshore, because evacuation is a major issue. You're many nautical miles away from land, so help is not just readily available. So you want to avoid as much as hazard or incidents as you can. So I think he talked basically around the constraint, because one of the things he mentioned in his and in the presentation is you talk about the constraint, because fields are already maybe like a brown field. There are a lot of things there, so you have to take those into consideration, and that would determine how you're going to select your vessel. The water depth will also play a factor and all of that. And then he also mentioned about the scalability, which I mentioned. So depending on your pocket and also the terrain you're dealing with, if it's near shore, you're probably going to be looking for a very low draft vessel. And of course, that means you're going to do only daylight operations. Nobody's going to stay there because you don't have accommodation space. But if it's a lot more deeper water, you may have a lot more accommodation space, and you can have maybe 10 personnel or more, depending on what the job requires. He talked a bit on certain areas we should focus. Maybe one of the things I'll add is, you know, in this whole survey stuff we talk about, or geohazard, they're actually into two buckets, I usually call them. One is analog, the other one is digital. So many of those ones you mentioned, as multi-beam, side-scan sonar, basket, all of them you had, they are all basically analogs. The one that is digital is the one that we usually deal with the 2D high-res or ultra high-res, as the case may be. I think he also mentioned a couple of things around where we cannot reach, which is emerging technology, has to do with the AUV, which is basically autonomous underwater vehicle. So this is actually in a place where we have no reach easily, because the sensors will not work from that depth. So you have to send something very close to the seabed, because if you watch from the assumptions in the geophysics that inform this particular design, you can only measure as much as 3 times the water depth. So if the water depth is so deep, you will not, in fact, it's just column water you're going to be dealing with. So you don't have anything really to measure. So that's why it's important to use either ROV, or you have to send an AUV right there. Then he talked about certain corrections, which are very important. So even though you have tailored your data acquisition design and all of that, but you also have to be mindful of certain corrections that you need to do. One of them is the one you have to use the sound velocity probe to measure, which is important for you to determine the acoustics that will allow you to control your dimensions. The other one is the DIMCOM, which you do before you do your multi-beam. So you need to have a DIMCOM you do the batch test and all of that, which will help you to say, okay, this is what I'm expecting as my result. You're looking at a particular controlled condition, and that will help you when you do your interpretations, you will make a sense of it. And I think there was a case he shared when they shot across a stream or river, right? And there are no corrections, so they had to invent, which is why they did that diagonal cross, so you can have a kind of intersections or cross lines, as you may call it, in seismic, to be able to give some credence to the interpretation. One of the other things he mentioned is that that ISBP is very important because it doesn't only measure the acoustic corrections, it also helps you to have an information about the temperature of the water you're dealing with, the salinity, and a bit of the pressure, which will help you in some corrections. Because if you're going to be doing the acoustics, they are going to be, to the high res, you're going to be needing certain corrections on your receivers. So those calibrations are very important. So those are very key details that I needed to bring out. Then he talked about the USBL, which is also a very key factor. The USBL is basically ultra short baseline, which is usually for measuring positioning. So it's also a very key factor for controls, because all of this is about precision. You don't want to go there and then you're dealing with a field that is in this room, probably with your survey. If you don't have the good coordinates, which you have referenced from your geomatics guys, you might find yourself acquiring a data that is actually in Alger. So that can actually happen. So those kind of corrections are very, very key. He talked about, in all of this, as geoscientists, all we're looking for is anomalies. So this is a kind of, going to the field, or what you call outcropping. But this time around, we're using instruments to measure them. That's basically what this tool is all trying to show. And what is important is, in as much as 3D gives us a lot broader view and mosaic of what we're looking for, the scale to which what you get from the 2D is a lot more because it's compressed. So you are able to see a lot more picture and make a lot more impact. So the things you call artifacts in the 3D are actually very potential danger when you see them in the 2D, right? So it's also things that you need to look at when you check out that. And then there are some other things we talked about in terms of the MAGI. So MAGI is quite expensive. You want to know where your pipeline routes, and of course, one thing is important in the MAGI configuration you want to do is, if you want to do a MAGI, because it's very expensive, you don't want to do an RF. For the one he mentioned, which is the unexploded ordinances that he mentioned in the UK, they had no choice but that, because if the risk attached to it is a lot more than the cost you're looking at. So that's why it's important to go that route. But for us in the oil and gas industry, a single tow is fine for us. But it's important to also have an idea of what your configuration or the route which the pipeline has actually gone through, so that you don't just do a lot more larger image. So bottom line is still scale, which is also economics, like my colleague has already mentioned here. In the soft bottom profiler, he talked about a lot of them, depending on what you're dealing with. Some of them can be towed. Some of them can actually just be under the vessel, and then it gives a lot more precision to what you're looking at. Then he talked about the geotech. So in choosing the scale of the vessel you're going to be dealing with, and of course, subject to the water depth you have available to you, that's the environmental condition, and also economics. So most times, if I were to choose that, like he has advised here, if I'm dealing with water depth of between 50 and above, I'll be looking for a drill ship. I'll call it a drill ship because it has both a derrick and also you can tow those geophysical systems on them. So that's also something you want to consider when you're dealing. So that way, you don't have to do multiple mobilizations. One mobilization can help you to take both the geophysical part of it, whether you're doing the analog or also alongside the digital. You will also be able to acquire your calls and your CPTs and all of that, depending on the depth you're dealing with, whether you're dealing with Euro codes or what have you. So those are also very, very important. Then one novel thing he mentioned was communication. So before now, you have to transport those through chopper to the field for corrections, and then they will check the first, like in seismic, when you do Bruce stacks, and then to check if there are any issues, and you can ask for a reshoot or something like that. So the same thing applies here. So when they check that, they will tell you, okay, oh, I need to rerun this line and all of that. But because of technology, things like Starlink has made it very easy for us to even transit the same data on real time, and they can do a quick processing and tell you, oh, this is not okay, can we rerun this line? Or when we are coming back, let's take it again. And that also increases our efficiency and also cost effectiveness for the project. Then another one he talked about is storage. So storage is also very key. And this age that we are dealing with, what do you call it, cloud computing. So we can keep things on server blades and it will stay a longer time, and we can have ability to retrieve them with a click of a button. Even though for geophysicals, it's a lot easier to use, but for things like geotechnical, it has some clause I will add. I say that because you're dealing with debris at the sea floor, a lot of things might have changed by the time you come to use this. So for us, best practices is to keep between 3 to 5 years max. You may want to do another geotech if you want to do in a new area, even if it's a brownfield, because the conditions of the sea floor may have changed, especially when you have dealing with a brownfield. So we consider that as a benchmark in industry, about 3 to 5 years for safety reasons and all of that. He talked about the software that we use to processing them for those multi-beams and all of that. They put them in Quincy software to do that. Then for the digital one, which is the 2D high-res or ultra-high-res, depending on the channel you're dealing with. If it's 24, 48, or 39, that's basically very, very fine. You're dealing with a lot more zooming. So that's actually why they call them ultra high density resolution seismic 2D. So those ones are done in Kingdom Suites. It was formerly owned, I forgot the company that owns it, but now owned by S&P. But it's the software we usually use to do that, and it's a lot easier to interpret those 2D sections. And then, of course, there are a lot of corrections that you do there. You remove noise, you do the correction sequences and all of that. One other thing he mentioned was when we want to pick our targets, yes, we'll have quite the data, like you said, but you don't interpret them in isolation. So you have to merge them all together. It's actually an integrated interpretation you're dealing with. So you have to compare what you have with the site console now with what you have in multi-beam and all of that to be able to say, okay, this is an active fact. This is what the information I'm looking at looks like based on their accuracy of imaging. So that also helps us, in dealing with all of those. Now, of course, if you look at the raw stacks that he has showed and also the raw information from maybe the multi-beam, you will see that the process one is a lot better, but you can also see the image in the raw one. That will give you either whether the data you're dealing with is quite okay. Of course, compare with the batch test you have done before you went to do all of those. Then I think he also mentioned, what was it again? The pipeline, new technologies are coming now with the emerging technologies. I'll be wrapping up with that. So just like the analog I mentioned, you don't need much of analog. You're going to be sending probes or unmanned vehicles. Even apart from the AUV and the ROVs, on the surface, even on the side of the scale of using certain boats for near shore, you also actually have things like what we call USVs right now. So USVs are a lot cheaper. Sometimes the kind of amount you spend for a 10-day operation in terms of fuel alone, let's say fuel alone, you can spend as much as 400 liters for that 10 days operation on a USV. That's how economic the fuel can be. That's not talking about the other, and it depends on the size of the USV. It can be as high as maybe an SUV. That's the high, or can be bigger, depending on the size of the USV you're dealing with. And that can give you the same data and reduce issues with man exposure to danger and all of that. So it's something interesting that we might also want to look at. Then this emerging technology on the 3D, so that's something that actually I'll go and study more myself. Thank you for that job. So I'm going to do that. And then the e-bus you mentioned. So those are kind of ways we can also look at whether there are opportunities for that for the industry. That is just to put in summary. And then I'm happy to hear that we'll have a competitor to the ArcGIS because it's very expensive to have that. The license is huge. So GIS is also very interesting to know. So it's an open for us to explore that economics of scale and be able to make good use of the information it offers. Then he mentioned about the reporting. So you have to chart them. There are a couple of, about usually in 4 panels, depending on the size of the data we are dealing with. So those are key things I think you want to take out of these studies. Thank you, Chris, for enlightening us. So,
yeah, just wait around. Just wait around. So thank you very much, Chairman. The next step is for questions and answers. The way we are going to do it, because of time, we're going to take 2 questions from here, physical questions, and then perhaps 2 online if we have. If we don't have online, then maybe we will give physical people one from the online guys. So please, question. Anybody, throw the question to anybody. It could be the speaker, It could be the panelist, but not the chairman of the occasion. Thank you.
You can throw to me as well.
Okay, fine. So he says the question can come to him. So, anybody?
Good afternoon, everyone. The panel of members of the high table. My name is Niyi Adebambo. I'm from Obafemi University, Ile-Ife, Department of Geology. I would just like to know that these survey techniques, are they to solve individual, are they to solve specific geologic issues or an integrated method? Are they to be integrated to solve issues or to be applied individually for specific geologic problems? That's the clarification I would like to seek. Thank you very much.
Do you want to take it? I can take it. Okay. Okay, thank you very much. So this is basically for shallow hazard. So hazard in the sense that anything that can be a misharm in the operations. And most of the times they are on the sea floor or slightly below the sea floor, maybe like up to 10 meter, 20 meter, like port marks. For instance, if I'm going to bring a rig to sit in a place, I want to be sure that that rig is not sitting on a gas pocket, that if it drills, it can actually cause a blowout because of the shallow hazard. Or it's sitting on the place that is not very soft. If you saw the map he showed, the place will have more stable reliefs. It's important to sit in that area than to say where you have bubbles. The bubbles can actually mean that it's on a stable floor. And when you put that, you can lose a hand of one of the legs of the jacket, the jack-up, the jack-up rig, and then the rig can sink. So a lot of things can go wrong. So it's basically for such operations. I don't know if I'm able to speak to your question. Okay, thank you.
All right, good afternoon. Thank you very much for the presentation. My name is Akisiri Abdurrahman. I'm a graduate of Federal University of Technology, Akure, and I'm currently having my NYC service with DigiConnect. So my question is on the processing aspect. I wanted to ask if it's considered measurement of more like error percentage, because there was a particular model I used recently on some data that integrated remote sensing with gravity and some other geophysical data sets. And I realized that the fact that I imported those data at the early stage, it's kind of over-exaggerated what I'm looking for. So does this particular model also consider, like the model particularly, has there been a measurement of its error percentage so that it doesn't overestimate or underestimate what is being explored for? And then I wanted to also ask if it's also consider the terrain, more like the geology of an area, if it works perfectly on continental than coastal, more like the comparison of the two geological this thing. Thank you very much.
Thank you. Do you want to take that, Chris? Or you want... Okay, the last part is he's talking about whether is the geology of environment of geology is continental. Is it specific, basically? I want to believe that he's referring to hard rocks and maybe continental shapes. So, yeah.
So in terms of the geology, obviously before the stage that we come to survey, and I probably talked about this more last time, was that there would have been desk studies and so forth done where any open source material would be considered, anything that's been done within the area previously would be considered. And this would then also likely be available at this stage. So you'd have some idea of what you were going to be confronted with. So this sort of takes the general picture that you've been given over a large area and tries to apply it to a very small area. So this is very location specific rather than being sort of generalized. And so when I work in the consultancy guys, as opposed to the actual site survey guys, I will write regional reports on geology over huge areas. And those would be supplied to the survey contractor to assist with their data processing and interpretation. So yeah, there would be a link.
If I would just add to what Chris has added. So your question is about scale. So I'm sure when you saw the chart, it was talking about 15-meter, sometimes maximum of 50-meter aperture. When I mean aperture, this is what you're dealing with. So it's a very small space compared to the seismic you're dealing with, about 500 square meter, for instance. So the scale, like I said, is a very small area. So, and also for things like multi-beam, it requires a good database of the environment. So the geomatics guys have some information, some pre-interpretation from maybe your seismic that guides them to what they are looking out for exactly. So it's guided, so it minimizes the error you're looking for. So it's well controlled. Thank you.
Thank you very much, Dr. Osim. I must commend your brilliant summary, as well as taking some of the questions as if you were even the presenter. Thank you very much, Osim. So we have, I think, about 2 questions online, because I say 2 questions here, 2 questions online. Please, if we have any further concerns or questions, please, we can talk to Chris after this presentation. So Abayomi Adejonwo, that's my boss. He says, thank you for the insightful presentation, particularly your perspective on the growing, Chris, I hope you're listening, growing role of AI in the offshore survey workflows. In your experience, which elements of AI-assisted processing, future detection, and automated quality control are sufficiently mature for operational use? What benchmarks are used to validate their outputs against expert manual interpretation, mitigate systematic bias, and maintain technical accountability? I think I'll leave, he has 2 questions, but let me just allow you finish this, and then I can read the second one.
That's a very good question, and it's become something very popular within wind farms, particularly because it's relative to scale. So with a site survey, oil and gas site survey, you might be looking at a kilometre by a kilometre or 2 kilometres by 2 kilometres, and that's manageable to a single person or 2 people. When you get to the wind farms, we've ended up with tens of kilometres by tens of kilometres of side scan acquisition, first of all. And so there's been a lot of money spent on automatic detection of point contacts within sonar data, particularly. Currently, I would say they tend to overestimate on the number of contacts within an area, far higher than what a human would. So they don't differentiate between noise and certain other things. So if you've got an accumulation of shell fragments and so forth in an area, that can have high reflectivity and look like a point contact. So they don't differentiate between that. But it has been driven by the fact that some end clients in offshore wind certainly take it as a number game, and if you only pick a fixed number of contacts, they're not happy and they want a really high number. And it has completely been driven by people just wanting a high number and to feel like you've looked at it. Now, they might not all be accurate, and currently the best boulder detection software we see has an AI element coupled with a human QC element, and I think that's where we're at the moment, in the fact that you still need to have a look at it, but the initial work of picking all of the targets and the measurements and so forth, which can be very time consuming if you're picking tens of thousands of boulders within a glacial sediment, can be significantly sped up by the AI starting point and then a bit of human QC. So that's certainly it. Within the other areas, there are moves for automated horizon and reflector picking, which again work brilliantly in soils where you've got really good contrast between the sediments, and so you get a really bright reflector. They still need a human element where it's more inconsistent. You've potentially got channels breaking horizons and so forth. So at the moment, you wouldn't fully trust an AI interpretation. It needs human input. But I guess the point with AI is as you build models and add more information in, it improves itself and it's constantly improving. So I think it will get there, but at the moment, it's definitely saving time, but it's not working just on its own. So it's got a place.
Thank you very much, Chris. So a follow-up question from Abayomi also, and that's the final one. Recognizing the spatial and temporal resolution limitations of conventional deep water 3D seismic surveys, to what extent can these data be reprocessed to improve shallow imaging for reliable geohazard assessment? And where does the need for a dedicated high-resolution site survey remain unavoidable?
Another very good question.
Of course, the question is coming from somebody who is a seismic person.
Yes. It's probably, and I would say 500 meters, you wouldn't really particularly worry about doing a 2D HR site survey. So generally, when we look at 3D cubes, and we get supplied a lot of 3D cubes as well to work with, from 400 or 500 milliseconds, they will often have as good a resolution as 2D data, particularly if that cube is a short offset reprocessed cube. So obviously the detail within your 3D data is within the offsets closest to the sources rather than the tail end of the streamer. The tail end of the streamer gives you great velocity control. So you still want that information because you want the velocity cube that will really assist your interpretation. But if you've got a short offset reprocessed cube and you've got 400 or 500 meters of water, there would be no point in doing a 2D HR survey. There would be limited point in doing multi-beam or sonar work unless you're going to go AUV, and that obviously costs money. And then once you get to 1,000 meters, you just work solely from the 3D cube, and the whole report will be based around the seabed pick of the 3D cube for the bathymetry, any features you can see on that seabed pick of the 3D cube. But anywhere under 200-300 meters, we're probably still in a conventional world of 2D HR survey, and that spot is somewhere between 300 and 500 where you'd start to think about it. And it would depend on the quality of your 3D cube. If your 3D cube is good and you can reprocess it, you probably just do away with the need for the 2D.
Thank you very much, Chris. Please, a round of applause for Chris. Thank you very much. So at this point, please, like I said previously, if you have further questions, you can see Chris after this meeting so that you can ask your questions. So I want us to quickly go to presentation of gifts before sponsors' remarks. Madam President, please. Thank you. Yeah. So, Mr. Chairman, sir.
You can stay at the center there, so that we can capture this. So thank you very much. Like the PE said, I was surprised when you summarized. It was as if you were the speaker. You know, a very good summary. Thank you very much. I saw you writing there. I said, thank you.
Yeah, this. The next person. Who? Speaker, please. The lapel.
Thank you very much. You were here in March, and you're here again. Are you a teacher or a lecturer or something? Do you do that with this work? Do you teach? Huh? You've done,
a couple of universities.
Yes, I saw that when you were presenting. Thank you very much. I'm sure many, must have taken a lot of knowledge from here today. Thank you very much. Yeah.
Mr. Dozie, one of the panelists.
The sponsor. Thank you very much, sir, for sponsoring this and also putting in your word to the topic. We really appreciate it. Thank you.
Thank you, Mr. Dozie, for this sponsorship. We sincerely appreciate. Please, let's the clap. Keep coming. Thank you. Thank you. Thank you. Mr. Ofebu, please.
Thank you very much again. Thank you for the love you have for this association. I know you're a member, but giving your time to it is well appreciated. Thank you.
So we will have the sponsors' remark. After the sponsors' remark or group or now? Okay. Okay. Group photograph now, please. I think the sponsor, the speaker and the chairman with the president, please. After that, which one? Is he okay? All right. Paparazzi, ahead. Please, the executive should come up. The executive committee members, please come up. Is this thing blocking? Okay. So, executive, please. Executive, you don't want to come? Come, please. Okay. Okay. All right, so finally, speaker, president, speaker and the president, please. So, no, madam, you've not finished. The assignment, yes. All right. Thank you. Thank you very much. Please, we'll now take the sponsor's remark. Mr. Dozie. Thank you.
Good afternoon once again, ladies and gentlemen. Frankly, I'm very impressed with NAPE, this professional body. I'm impressed with your philosophy. I'm impressed with your activities. I belong to some professional bodies, but I see the difference. You have been consistent and persistent in sustaining your style and the way you do things. I'm amazed at your strategy. little wonder that even the octogenarians with whom I'm very familiar still find time to attend your monthly technical meetings, in spite of the heights they attained in the oil and gas industry before they retired. I'm yet to see a professional body in Nigeria that will have shown me the impressive status that you have demonstrated in your way of doing things. One of the things that amazes me is the opportunity you provide for the younger ones who are coming up, the university students. Other professional bodies do it, but the way you conduct your regular technical meetings provides yet other opportunities for learning. You're a professional body that I have given guidance, and very serious guidance, to the oil and gas industry in Nigeria. And one of the things I note is what you do, what you decide here, is what the individuals, the constituents of this association, take back to their respective companies. I mean, take for example, my Oga, my boss, Chief Chambers Uruwari Oyubo, who has been a member of this association over the years. If you take your decisions, if you took your decisions and this is the way to go, would he not have applied it when he was the group managing director of NNPC? Of course he would. He'll be tending towards that direction. Same thing applies to my Oga, Chief G. Morife. And in like manner, to each and every one of you who belong to other companies, I see the likes of Odedere, I see the likes of many others who belong to many companies. There's no doubt that what you have arrived at, your philosophy, the way of doing things, is a way of communicating these things to the respective companies and thereby shaping the industry. And I encourage you to continue to do this for the next steps. If you take note of what's going on now, there are several activities all over the whole world, not just in Nigeria. The industry has just suddenly picked up in Nigeria, but at the same time, all over the whole world. And I would suppose that you will keep pace with the demands of the industry, particularly in Nigeria. And for this reason, we thought we'd be delighted, I'm delighted for this reason for my company, on behalf of my company and myself, to sponsor this technical meeting. Our associate did in March. Here we've done it again, and we are considering to do a lot more in the future. So I encourage you to please keep it up. I think we will soon be applying for a corporate membership if you have such status for the Seis-space. We will be delighted to have membership as a corporate body. Once again, I'd like to thank you for the opportunity you have provided us to sponsor you. If you turn over an olive branch to me once again, we'll be delighted to do it again, like I said. And so whatever you are doing to keep these very senior citizens on the ball of their feet, doing what they're doing, please keep up with it, hold on to it. And for the young ones, do not, please, miss the opportunity provided by NAPE On behalf of Seis-space Geosciences Limited, I would like to thank you and encourage you to continue with the good works. Thank you.
Thank you very much, Engineer Irrechukwu. Yes, we have a corporate memberships section, so we'll reach out to you. Also, thanks for the kind words. And then, like Oliver Twist, we will come for some more, sir. Thank you. So we'll quickly go into announcements. Tune, can you project, please? So while he's projecting, after the announcements, then we'll take a birthday wish or birthday song for one of our fellows and member who is above 80 years and is celebrating his birthday this month. So announcements, technical business meeting. So we have that for Warri, that is planned for 20th, 26 and 27, sorry. Also, we have for Uyo Calabar chapter, that is planned for the 31st of August. There's also another technical business meeting for the North America chapter, that is planned for the 4th of September. We have, for any inquiries on this, please let's reach out to Lawrence Oswago of NAPE Secretariat. We have the NAPE UAP lecture series. That's coming up on the 22nd of August. We can see the poster there. The UAPC chairman is anchoring that, and the dates are all there. The NAPE Summer School, yeah, so that is supposed to start next week, but we've really not gotten the number we want. So most likely we might move it just some days or maybe a week or thereabout so that we can get to a certain number and then we can execute that. But we have very appreciable number at this time, but we are not there yet. So as soon as we get the number we want, we will carry that out. Actually, it's supposed to be next week, but it might have to move by 1 week or thereabout. And I want to appeal again to our seniors and those who are capable and those who are well-to-do. Please, let's sponsor one student or one young professional to attend this summer school. It promises to be very impactful because we are going to talk about what is in thing in the industry at the moment, which is the AI thing, AI ML. So it's going to be rich. We have the NAPE essay competition, reimaging exploration, how emerging technologies can unlock new oil and gas reserves in frontier basins. So that competition is on. I think you need to submit there's call all students and graduates and young professionals. So there will be a submission of write-ups and all that. Submission period is August 18 to September 18. So it's ongoing at the moment. Then the next announcement is on election. I will quickly call on the chairman of the electoral committee to address us on this. We are gradually entering into the election month, which is, I guess, September. That is when the voting will start. So before then, it is customary with us that we present the candidates to you. Come up, sir. We present the candidates to you, announce their names, so you can make your choice. Thank you.
Thank you very much. I'm actually not here just to announce names. If it's to announce names, we already have the names on our platforms. But I'm here to say, let's take the voting seriously so that we can have the right people. Our brother they just told us about the good work that is being done. But anybody would agree with me about the work that is being done by this current executive. Our president is coming up with initiatives, our president and the executive, coming up with initiatives that are new. Look at the academy, for example. It's not just any academy. It's a world-class academy that this executive is coming up with. So please, let's take this election seriously. Pay your dues, because you have to have paid your dues to be able to vote. But let's have the right people so that NAPE can continue to be there for us. When we are 80, when we are 90, we can still be proud to say we are NAPE members. Okay, so I would announce the names because of time. We have two people who are vying for the position of president-elect, Mr. Ehi Bazwaye and Mr. Karim Folorenshaw Fatai for president-elect. For the position of general secretary, we have one person, Mr. Austin Mbemere. For the position of the assistant general secretary, there are 4 candidates, Mr. Gideon Oyeyinka, Dr. Julius Onwuka, Mr. Olusegun Olonode, and Dr. Ganiyu Mosoro. So those are four people vying for the position of the Assistant General Secretary. For the position of Financial Secretary, we have 2 candidates. 2 candidates for the position of Financial Secretary, Olusegun Eku and Mr. Lucky Iwu. For the position of Treasurer, 2 candidates, Dr. Mohammed Mala and Dr. Osim Ogboke, we already know him. For the position of Editor-in-Chief, 2 candidates, Dr. Chidozie Princeton Dim. I was actually also supposed to have asked for those who are present here to also stand. I missed that, okay? But maybe to make it uniform, those who are here and those who are, we would go to the platform and would see their pictures too. That's also appearing here. Okay. So, and for the other candidate for editor-in-chief is Morufin Adabanji. I'm sorry I didn't pronounce that too well. And for the position of publicity secretary, there are 3 candidates. Mr. Ibrahim Dong, Ms. Ogechukwu Flora Anusiobi, and Mrs. Abiola Shoremeku. 3 candidates for the position of police secretary. And then the last but not the least, for the assistant editor-in-chief, just 1 candidate, Professor Oladoku Oluwanjana. Okay, sorry again about the pronunciations. So those are the candidates, but like I said, I'm here to say, please, let's take this seriously. Vote for the best so that NAPE will continue to be the one association, one technical association in this country. Thank you very much.
Thank you very much, Electoral Chairman. You've done noble. You've done wonderfully well. So, in continuation of the announcement, the NAPE Academy, which recently had it, it was carried out, I think this month. We did it this month. So, that's the picture of that event. And we're hoping that the effects of that workshop will start materializing, the positive effect, I mean. We also, the registration for the 2026 NAPE conference is ongoing. Early bird ends on the 1st of September. Please, I would urge us to, if we have not registered, let us do so. If our companies have not registered us, please let's remind them, because once it's 1st September, we will now apply the next rule, which is more money. You can even, I mean, it's possible your company can send in the list now and tell us, okay, reserve this for so and so persons. We'll get back to you. It's allowed. So as long as it's done before the 1st of September. Fundraising for the purchase of a permanent NAPE site, or secretariat, sorry, It's still ongoing, and we urge us to please try as much as possible to pay up. And then for those who have large hearts, please, if you give us more than what we have, allocated to you, we will be willing and very happy to accept. And then finally, on the payment of dues, no association strives without dues payment. Please, let us try as much as we can to pay up our dues, because that's what we use in, working and handling the secretariat as well as NAPE on a day-to-day basis. Thank you very much. On that note, I think the announcement is done. And okay, sorry, I missed this. Know your candidates meeting. I think that is going to be organized by the YP. They are going to, and it's basically for just president-elect. This time around is for everybody. Okay, because during my time, it was only for president-elect. I wonder what changed. Okay, because it was okay, that's fine. So there's going to be Know Your Candidates, and that's going to be organized on August 22nd, 2026 by 7 p.m. Please, it's going to be online, and we appeal to us to log in and hear from them firsthand. The information and the log-on details will be, sent and then sent to us, and also it will be on the website. Thank you for reminding me about this. So, please, quickly, let us honor one of us who recently celebrated his birthday. Tunde, please, can you project? Time is fast spent. We need to handle this quickly, and then so that we can return back to our various offices. Please, the music should go with it. Please, please, please. Tunde, you're not ready. Okay, if you're not ready, I can take the vote of thanks, and then perhaps somebody is smiling. I don't know why. Tunde. Yeah, they should put the music. That's all we need. So we are going to celebrate Dr. Sir Felix Njoku. He's a fellow of NAPE. KSJI is Knight of St. John of International, and then a JP, Justice of Peace, if I made that pronunciation correct. So he's celebrating his birthday. I think he celebrated it this month. Please, can we rise and appreciate him? Thank you very much. He has contributed enormously to NAPE. So, his name is Dr. Sir Felix Njoku. We can see his awards. Happy birthday. Happy birthday. To you. Birthday. Thank you. Thank you, thank you. We can take our seats. Thank you very much. Thank you. So I want to quickly give my vote of thanks before we retire for lunch. So on behalf of the President, the Executive Committee of NAPE, and the entire membership of NAPE, I want to say, sir, thank you very much for taking this slot to sponsor NAPE August technical meeting. We are eternally grateful. We are so happy. And like I said, we'll come to you. So we'll come back to you. So I want to thank our fellows here for finding time to come. It's not easy. A lot of moving parts. Either you're here or there and all that, but you could find time to come. Thank you, my seniors and fellows of NAPE. Also, I want to thank members who are here present, and especially our students for finding time to be part of this month's technical meeting. I will always encourage you, keep coming. You learn a lot, you network, you meet older colleagues and all that, and then from there, you can move to the next level. I started that way. I keep saying it anytime. I started that way, right from Port Harcourt. I was attending NAPE meetings as well as NMGS. So on this note, I want to thank everybody for finding time to come, and then wish us safe trip back to our various destinations, including our offices and all that, and then have a good time of the rest of the day. Thank you very much. For lunch, for lunch, for the sponsors, the fellows, this is our serving point. Please, the serving point for the speaker, the co-sponsors, and the fellows here present, please, this is our serving point. The rest, we have 2 serving points. One in that room, and then the second one at the extreme there. So please, let's use these serving points and then have our lunch. Thank you very much, and have a blessed day ahead. Tunde, can you give us some music while they go to grab their meal, please? Music, music.
ta ló lè bá mú kọ́ńtà yẹn wá ní ìjọba ń sọ fún bọ̀bọ̀ ìkọlọ́ máa mú wá lú.
Táíwò.
Pé ọgbọ́n ògbé mi bọ́ màá gbẹ́ náà. Àwọn ọmọ yẹn máa fún. Ìwọ́n gbọ́n kò yẹ kó máa di àbó yìí. Ló ṣẹlẹ̀. Ó dà. Níbi àìtẹ́bù náà. Jọ lọ check níbi àwọn stool yẹn.
Noise, mute it, let me pause it and play it back.
Ọkọ̀ wo bí podium yẹn.
Hold on, let me. Oh, ebe òṣìṣẹ́ mọ́.
Ṣé bàbá ẹ̀ rí kìíní yẹn já? Sanwó àbí kí ló ń korúkọ?
Táíwò.
Táíwò, ṣé o rí mẹ́? Mo kàn wọ́n ti fi fóònù ẹ̀. Kò sí bẹ́ẹ̀, ó ti wọ ẹlẹ́ẹ̀kejì tí mo lọ ní.
Àbóbi sórí pódíọ̀mù ni.
Kò sí bẹ́ẹ̀, ó ti wò ó.
Kí àkèbí ò lè sọ̀rọ̀ mọ́ o. Táíwò.
No, mọ option, ó ní option, ó ná ẹ dúró.
Kò gbé option jáde.
Ó ti gbé option jáde tẹ́ òkè.
Kò gbé jáde tẹ́lẹ̀ ó ṣe bí jáde ni.
Ó máa fi báyìí. Export,
And check, it's playing now.
Hey, olúwa.
Gba kí wọ́n ṣe jáde ní ìmọ̀ ọmọdé tẹ́tí lọ pa.
Ilẹ̀ náà, mo ti mú ọwọ́ máa nílò wà.
Ilẹ̀ ní kí n máa ń gbà.
Ní kò páàkì ní rẹ̀.